Hello, guys. Welcome to the Techo Genius Academy. So today I am here to discuss the next topic on Linux device drivers. Today we will discuss about the bottom half. So earlier, what we have discussed was interrupt handling. We can say as a top half. So top half is nothing but our interrupt handling concepts and all. So in interrupt handler. Which is doing the less work. If you want to go further and do more work, and you want to make your process like it will be busy for some time, then we will go for the bottom halves. Let's get started. So in a bottom half, it's divided into four bottom half mechanisms in Linux. First is work queue, then threaded IRQs, then soft IRQs, then tasklets. Basically, developers are using tasklets and work queues. So first we will cover the tasklets. So like how we can use tasklets in Linux device drivers. So what are actually tasklets? So tasklets are used to queue up the work to be done at the later time. Tasklets can be run in parallel, but the same tasklet cannot be run on a multiple CPU at the same time. Means like you have the same tasklets and you have to run on a multiple CPU at the same time, then it will be not possible. But the different tasklet you can run on a multiple CPU at the same time. So also each tasklet will run only on the CPU that schedule it to optimize the cache usage. So how we can declare the tasklet and how we can schedule. So you can say is see here scheduling the bottom half is using the call of tasklet underscore schedule, and we have to pass the name which we have used while declaring the tasklet. So declare underscore tasklet is the main part. So where we will use the argument as a name, second argument will be used as a function, and third will be your data. Declare underscore tasklet is nothing but it's a macro. It's just used to create the tasklet structure and assign the parameters to that structure. Tasklets are atomic. Why it is called as atomic? Because it cannot use sleep, such as synchronization primitives, such as the mutex semaphore, etc. from them. But we can use spell locks. So we can create tasklet in two ways. One is a static method, and other one is a dynamic method. We'll first see the like how we can write the static method. Declaring the tasklet, and after that scheduling it, that will come under the static method. So in a dynamic method, we have to use the tasklet underscore init call to make it dynamic. So we don't need to declare the tasklet in that point. So the structure of the tasklet is like the next state, your count, function, and data. So what next is? So next is the next tasklet in the line, which will schedule it. And the state is the state denotes the tasklet state. It's schedulable, or it's in a run state, and all these things. So it will denotes as a state. Count will be your it will just hold a non-zero value, so if the tasklet is disabled, and the zero if the tasklet is enabled. So we'll mark it as zero. And the function that you need to pass this will be the main function of the tasklet, so which we have declared, as you can see here, what a tasklet underscore function, and we are passing the data. So that will be your function name, which we will pass as an argument in the tasklet structure. And the data is the data to be passed to that function, or whatever the data is. Just to enable the tasklet, or like few of the calls we can use while implementing the tasklet. If you want to enable the tasklet, you can use the tasklet underscore enable. For disabling, you can use the tasklet underscore disable. To schedule, we will use schedule underscore schedule, and to kill that, tasklet underscore kill. There is another one, tasklet underscore init, which we'll use in a dynamic method. What we can do is, so now we can just jump into the terminal just to see like how we can write down the code. So for that, I just need to go to terminal, Control Alt T, great, sudo su, yep. So cd ldd cd, yep. So we have discussed the interrupt handler, IRQ handler in this in the previous video. So what we will do now, we will just declare a function here, void tasklet underscore fluency unsigned long some data, then we'll declare the tasklet, declare underscore tasklet. First we will pass the tasklet name, second will be your tasklet function, and the data. Then we'll write the tasklet function. Void tasklet underscore function unsigned int data. Here we can use the printf con info tasklet executing the tasklet function. We can just print the value. Yeah. So now in a handler function, what we can do here, we will just schedule the tasklet. So whenever the interrupt occur, it will create the tasklet function too. So what will happen, IRQ handler is just for the top half and occurring of that interrupt and all. So if more work is there, so we can do it in a tasklet function. So right now I'm just printing the some data and all in a tasklet function. So later on, what we can do here, we can use a spell lock here, so it'll go to sleep and all these things. So so actually in tasklet, what we have checked is like we cannot use sleep such as this synchronization and all these things. We can use it in a work use. So what we can use here, we can use the spell locks. Okay, so in a tasklet function, we'll try to write the some spell log code and all. For that, I need to create some another video for explaining you like how we can create the thread, and in thread how we can execute the spell logs. So later on we can add a few of the codes in the tasklet functions in a work use and all these things. So first I just want to go through to show you the flow and the understanding of basic tasklet functions and basic tasklet, how tasklet will work. So later on we will go jump into the advanced Linux device driver series. And okay, so tasklet underscore function. So we will schedule the tasklet here. Great. Yeah, that's it. So we have cleared, and we can just check here the IQ number, share the crypto device. Yeah, everything is good. Yeah, good to go. Make, oops, some conflicting errors. We are cutting. One sec. Oh, sorry. We can use here. Sorry, print K. I'm just confused between the user space program and the kernel. So this is kernel programming actually. Yeah. Sec. Like that. Okay. Yeah, it's done. So now we can insert it. Okay, file exists. I'll just remove this. The message hyphen C. Yep. So inserting chr here. Great. So interrupt occur, and after that we are executing the tasklet function. So why it is coming again and again? Because I am typing d message in, after that I'm entering, so it will occur so many times, so that we are mentioning the keyboard interrupt. So you can use some another interrupt to just to see, like you can use timer, you can use mouse interrupt. So if you have the desktop and also you are connected to the USB or something like that, so you can use the shared interrupt, you can use the interrupt number as 11. So or what you can do here, you can shift your tasklet underscore schedule function to the underscore init function. So that will make you the difference, so you can just go and check. Okay, so we are executing this tasklet function. So in this way, like we can do the tasklets. So what we can do now here to make this thing as a dynamic, so we need to make some changes here. As what we can do, we can create our tasklet, then yeah. So we just commented this is a static method. Yep. So here we need to mention, yeah, so here we need to mention tasklet underscore init. Tasklet underscore init, your tasklet name, tasklet function, comma 1, are you 0 for enabling dynamic method. Yeah, so this you can do it. So for that also, one sec, we have we have initialized that, but for dynamic method we need to create the memory for this too. um, Tasklet equals to kmalloc. Here I'm using kmalloc, kernel malloc. It's just similar to the user space malloc function. Size of your structure of your tasklet, where I've mentioned like the next count, your the whatever the arguments that you are mentioning there, so that you need to pass here. So, and the flag gfp kernel. So when we'll go to the memory management, I'll explain you each and every bit of the kmalloc, how we can use the kmalloc, what will be the what are the main flags. There'll be a GFP kernel, there'll be a GFP underscore DMA. So how we can create the memory in the kernel and all these things. So this is the example, like this is one of the example to create the memory in a kernel. So we can just display the error message, like if something goes bad, so we can come to know that a tasklet is not executed properly, with that the memory is not allocated properly for the tasklet. Cannot allocate the memory. Great. So here we can just go to IRQ, and it'll just free our IRQ. So we have initialized the tasklet. So now what we will do in a exit function, we'll just use the kill command, kill tasklet underscore kill call to kill the tasklet. So this is great. This looks fine. This looks fine to me. So here, what I can do here, so I just need to create the structure for that. So I can mention here struct tasklet underscore struct star tasklet, which we have used. Great. So now we are good to go. Make, okay, somewhere came, I just need to see. Okay, so we don't need to pass address here. Yep. So everything goes well. So now what we can do here, we will just insert the module the message. Yeah. So as you can see here, executing the tasklet function, and then interrupt occurred. So like you can differentiate these things while adding more test cases, more methods, like in a tasklet function, to differentiate like how these tasklets are working. Okay, so this is for this tasklet function. So what we will do here, on the later sessions and all, we will try to cover the spell locks. So I just want to show you that how you can create the threads, that kernel threads in a my Linux device driver or in Linux kernel, and in a threads how we can use the spell locks. Okay, so then what we can do, what we can try here, we can add that we can just try to use the spell locks, or because you have the understanding, then we will use in the tasklet functions. Or what we can do, we can use the atomic operations. So there is one another concept in a Linux device driver, and in Linux, the atomic. So I'll make sure that I'll introduce you to that topic, so that also we can use here. Some counters, timers we can add into that, so we can do some modifications and all. So hope you like this video. So please don't forget to like, share and subscribe. So and I'll make sure that I'll upload more and more videos, and I'll try to make good stuff or good content, so you can have a great idea about this Linux device driver. So we'll catch up again. Thank you so much.